Hi, I'm Jerry Herbst.
And I'm Chris Martin, and we're with Elkhart Brass. And we're here to tell you about our recent trip to England, where we traveled with a group of international fire service instructors for a very unique training event. We're here to tell you a little bit about it.
What we want to share with you is the concept behind the event, what the objectives were, who was involved, and where we went.
The trip was centered around the first ever high-rise operational tactics thought leadership event at the UK Fire Service College. It was a 2-day event with 1 day of lecture and 1 day of hands-on.
Prior to that, we spent 2 days doing live burns with top instructors from all around the world. We wanted to get a full grasp of their approach to firefighting as well as pass along our approach to them. We had accumulated A-level players from the US, the UK, Italy, Ireland, Australia, all over the world. One of the key objectives for us as Americans was to have a deeper understanding of gas cooling, not what we've read about, but to actually do it so we had a better understanding of the tactic.
The event was a chance for us to show our new European XD handline nozzle. Anytime we enter a market, it's important to understand the unique needs and requirements of that market. At the end of the day, we're here to make the products that you want, not the products that we think you want. Our group flew into London Heathrow from all different parts of the US, where we met up with the rest of the group that came from other parts of the world. We then boarded a bus, driving through the English countryside to a small little town called Moreton-in-Marsh. Moreton-in-Marsh is home of the UK Fire Service College. Once we arrived on campus, we were greeted by the staff, and they were absolutely great.
Gary! Nice to see you, mate.
Everything that we needed was right on campus. There were several restaurants, dormitories, all kinds of training facilities, and even a pub. Once everyone got settled, we managed to find our way into town to find a legit English pub. And as you can imagine, there was one thing that the conversation revolved around: fire.
20 hours in example. It's all burnt out.
How do you check this off? How do you maintain it? 200 liters. It took 200 liters until we're getting 400 liters. There'll be some scrap cars down here that have been set fire to. Set fire to one here, one on the corner.
The next day, we took a tour of the facility.
These have all been burned over the last week.
The UK has a national fire service, so this is the type of facility where every firefighter in the UK goes for their initial training.
So there's a train that's derailed. There's a full-on railway crossing. You can put cars underneath them.
The site was a Royal Air Force base built during World War II, and in the 70s was converted into the Fire Service College. I was awestruck with the enormity of the facility and its capabilities. The grounds are extensive, and there's all manner of burn buildings, all Class A, that range from converted shipping containers up to large simulated commercial structures and high-rise buildings.
So this one on your right, and then when you want to get out and have a look, it's basically set up as a shopping centre. So we burn, it's carbonaceous burns throughout the building. We can burn right from the top floor all the way down.
These large structures are all about hose movement. With a good loading, you can get an overpressure that sits pretty much about an inch off the deck. We leave certain doors open, whatever you want to do, for them to be able to find the flow path.
I'm impressed with the size of the facility, but it's spread out enough where you can operate independently in different areas of tactics without interrupting each other. A lot of what we get in the United States is you'll have 5 or 6 evolutions on one training ground and you're basically walking all over the top of each other.
The facilities here are amazing. They really give a great space to contextualise the broad spectrum of structural firefighting. The building we were just in with the high ceilings and the pitched roof is an amazing way of contextualising observation of fire gases and how to deal with those fire gases inside that building.
Some of the group got fitted with European-style turnout gear. Instead of coats and pants, they call it tunics and trousers.
Tunic, that's a term I've never heard.
Tunic, yeah.
Zipper's on the left side. They drive on the wrong side of the road and they put the zipper on the wrong side of the road.
It's a little lighter weight. I really like it. The coat is shorter than ours and it's a little tighter fitting, but it's very good. It's very maneuverable. I like it.
It's like I'm gonna go on a motorcycle ride, but yeah.
Oh yeah, you can do that.
Yeah.
too tight.
We also took some time to learn how to use their equipment. Probably the biggest difference for us was their SCBA.
Open the cylinder, so pull the knob out, turn anti-clockwise when we do it. As soon as you do that, it will activate the bodyguard.
So we just spent a lot of time on going over it. The form and familiarity was a little bit different than what we're used to. Since this is such a critical piece of equipment for live fire, it was important that we got it right. The way they manage their accountability tags is also a lot different than what we do in the US. They'll delegate somebody to handle accountability and air management. Essentially, a key will plug into the SCBA and they can plug into an accountability board that'll show consumption levels, status of the crews, and so on. Their apparatus, or what they call an appliance, are obviously a lot different than what we have in the US. They're a lot smaller in order to cope with older, narrow streets, but they're very capable, and they carry up to 6 firefighters. They don't have traditional hose beds like you'd find in the States, because most of the time their primary attack line is a high-pressure hose reel, 22 millimeters in diameter with a variable flow fog nozzle. They call their nozzles branches. Their typical fire flow is somewhere around 200 liters a minute, so around 45 gallons per minute. This flow rate might sound shocking to us, but they have a much different built environment and much different infrastructure than we do. Most everything is masonry construction. They simply don't have the large water mains or water supply to support higher flow rates. And the firefighting style is more of a compartment style fire than a structure fire.
That theme surfaced again and again throughout our visit. The infrastructure drives the equipment choice and the tactics used. We did note that most appliances or pumpers, whatever you refer to them as, do carry about 2,000 liters of water, which equates to about 500 gallons. Keep this in mind as you continue to watch the video.
After talking about how things are so different in Europe, we also want to point out that the job is still the same. The mission is still saving lives and protecting property. They pride themselves on aggressive interior attack, just like we do.
Once we were all kitted up and familiar with their equipment, as an instructor group, we spent the day discussing tactics and building props for the high-rise event.
Strap it down to secure it, and then the idea there is to keep everything nice and tight. Anything's flopping around, anything that annoys you, it becomes a problem as you're hiking up, especially if you're going for a long trip up. It can just be that first piece of the domino that falls, because then you're paying more attention to that than anything else, and then it leads to problems. So if we can handle that all from the beginning, make it nice and tight, everything goes better.
With a primarily high-rise focus, we talked about hose packs. It was very interesting to listen to the other instructors discuss the challenges they have where they fight fire.
There was a huge increase in development of tall buildings in Dublin, and I was given the project lead, and the very first thing I started to study was the facilities within the buildings. And the first thing I noted was that the standpipe systems, or we call them dry risers, they were not capable of supporting fog, because fog needs, as you know, a certain pressure in the nozzle to generate the droplet size. The standpipe systems were not capable of doing that once we went over 10 floors. So we had a problem, and the problem wasn't solvable with fog nozzles. So we started to train with smoothbores. So as it turned out, it solved more than one answer for us, because when we moved to structural firefighting, or for high-rise firefighting, the smoothbore was the solution. So what we have now is we use fog for compartment firefighting and smoothbore for structural and high-rise firefighting. So the guys like both.
So the next day we did live fire as an instructor cadre. We did this in their commercial fire prop. They would light a couple fires and we would go in as crews of 4, locate and extinguish the fire, and do searches along the way.
Now this scenario being a commercial fire, we were outside of the realm of the 22 millimeter hose reel we talked about earlier. We went with a more traditional lay flat hose, like a 1 3/4, something we would be accustomed to in the US. The British instantaneous coupling is fast and secure, but much bigger than we're accustomed to in the United States.
Oh, it was brilliant. So we were conducting a live fire drill here at the facility. We made entry through the door up there.
Communication was difficult. We had 4 people. We had someone from Ireland, we had someone from Italy, myself from America, and we had a firefighter from Australia.
Went down a set of stairs replicating a basement fire, and then we had to find 2 sets of fire in the basement, and the basement was fully partitioned.
We had a good plan. The hose charged properly. Managed to get to where we were going. Unfortunately, we missed the door. We missed the door and we went around the building. We had trouble locating the fire.
Is it around the corner or is there a door into that room?
So it was a good drill in hose management and communication, bumping up, bumping down, managing the pinch points, we call them, on the corners. And then we had to retreat with the hose and try another way to get in and locate the fire, which we eventually did.
The hose moved very well. There wasn't that much work involved in moving 1 3/4 hose. Whereas normally from this side of the pond, because we're so focused on booster lines, we would have made a big effort on that. That would have been a lot of hard work. So that part I thought went very well.
We'd usually just have 2 inside. Having the 4 really made that hose work so easy. Like being on the branch, I never needed hose.
As a fire service in North America, I think that we do really well with deploying hose and managing the reactionary force from the nozzle.
Porterò innanzitutto lo stendimento del Denver Method per fare le tubazioni. Una stesa agevole sulle scale e uno spiegamento veloce all'interno dell'edificio.
We were in the area where there's two seats of fire as before the crew comes down with the line, so it's hot. The value of a tick when you're working in a burn room, right, in this case where you're observing, I'm glad I had it, because watching the change in temperature was 1,000 plus at the ceiling. I mean, just rolling orange fire. The bottom line is the fire dictated a solid hit of water, and that's what it got. There was no gas cooling that I saw. It wasn't even communicated. It was what I would call a traditional attack. It's the same thing my company would have done, and I think your company would have done.
But in fires like this, high heat conditions, a longer type stretch, could have opened the pipe, get some cooling, because you saw the minute that pipe was open, the temperature drops on that thing too. So sometimes crawling up on the seat of the fire, but also in advance of that, retract the room, retract the gases, cool the environment, and make your push.
It's absolutely critical that you have clear and concise communication. Especially with the breathing apparatus on, it's difficult to communicate, so you have to get closer and you have to make sure the message goes back and forth all the time.
Pass back the message. Fire's under control. Fire's under control.
L'unica barriera è la comunicazione tra le maschere, che rende la comunicazione troppo sorda, ma il lavoro dei pompieri è uguale dappertutto e quindi quando senti la tubazione che viene tirata tu mandi giù tubazione e non necessita parlare molto.
I've been in the fire service for 24 years. I've never seen a facility like this. I've never seen a facility like this anywhere. It is fantastic. In my jurisdiction, we have 1 burn tower. Unlike this facility, we have multiple burn towers. And every single firefighter on my job understands the layout of that building because we've all been in it our whole career, so it's going to be very, very difficult to trick us. So this provides extra value because I've never been in this building before, and to come down here in a live fire situation where I'm not familiar with it, it is very, very similar to real-world firefighting.
2 40-foot containers, another 40-foot container along the front there.
On the afternoon of the live fire day, we had the opportunity to do some fire attack scenarios in shipping containers, like we'd have in the U.S.
So what we want to try and capture is, a smooth bore approach with conditioning your approach. Watch the reduction in temperature and do the same thing over here with the gas cooling approach.
In these live fire attacks, we were able to learn each other's tactics and then go try each other's tactics. So that we're all on the same page, we had demonstrations by 2 subject matter experts. The first was by John Chubb of the Dublin Fire Brigade, where he explained gas cooling.
The Swedish offensive method is effectively droplet size management. So the basic concept is small droplets of about 0.3 of a millimeter will evaporate in smoke layers and will steal heat energy from the smoke layer because of a concept called the latent heat of vaporization. Huge amount of energy is taken from the gases to cause that water droplet to vaporize. Now, gas cooling is not extinguishment. and it has been confused by some as extinguishment. So if you break out a firefighting operation into two separate work streams, one, the approach, getting to the fire through smoky rooms, the fire is a good bit away, and then when you see the seat of the fire as the second work stream. So to make the approach route safe, we cause water to evaporate in the smoke layer and steal heat energy. It's critically important that you control the flow path at the door. Otherwise, what you've just cooled is gone out the door. So as the guys approach from one room to the next, they're cooling the smoke constantly. And what they're trying to do is suspend droplets in the gas layer without touching the ceilings and the wall, because that will generate steam, which is not conducive to your comfort, or it's not conducive to maintaining a thermal equilibrium in the room. We don't want to bring the heat energy down to where you are. So what you're going to see the guys doing is you're going to see them cooling constantly the smoke layer. When they arrive at a line of sight to the seat of the fire, instead of making small droplets, they will switch to straight stream and make big droplets, because big droplets are better at putting out burning surfaces much better than small droplets. So what they're going to do with the branch is show you how you can manage droplet size. So you have a couple of options. With this here, you have a flow ring selector. Generally for a domestic fire, you will set it at a very low flow rate so that the internal pressure is increased. When they need a bigger flow, they will crank that up to suit the surfaces that are on fire. So it's not really that complicated. They will cool the smoke when they can, and when they see the seat of the fire, they'll deal with it. And after that, the skill is in the width of the cone angle. So what you will see them doing is adjusting the width of the cone angle so it doesn't hit the ceiling or it doesn't hit the walls. And then the other thing is adjusting the length of the actual burst or the pulse. Again, we don't want that to hit the back wall and just generate loads of steam, because we want it to stay suspended in the gas layer.
So if we're crouched down for a long time, searching for something, searching for heat, searching for where the fire is, the branch person will just be doing that to protect the area that they're in. I want to advance that way, making sure that all of my boss is in the overpressure, in the direction I'm going, cooling the gases ahead of me so I can go down and advance on that fire. And then when I see the seat of the fire, all the way to the right, all the way to the left, water on the fire.
Just to finalise, it's not designed for big spaces. It's designed for a maximum space size of about twice the size of that container. After that, you will not get those droplets to travel. They will actually vaporise before they get to any area that you're trying to cool the gases. So it's small domestic rooms. So we don't have a hang-up about smoothbores. We use both in Dublin. But what I will say is, for a domestic fire, right, in our built environment made from brick, there's no lightweight construction. There's very little timber frame compared to North America. We're pretty confident that the fire will stay in the room of origin, where you guys have much bigger challenges than we do. So this works for that environment, but there are trigger points. If the fire is no longer ventilation limited, and there's windows broken and there's doors wide open, and the fire is clearly fully involved and it's fuel limited, we're not going with this. We're not going with this technique. So for our built environment, this works, and flowing around 45 gallons a minute. So I'm not trying to convince you guys to do it in your world, but it works in ours.
This was followed by Keith Stakes of UL's Fire Safety Research Institute and an explanation of surface cooling.
Quick high level on the American approach. So, our building stock and our fire load lends us to surface cooling compared to gas cooling. Right, so our building stock in the residential environment, primarily type 5 wood frame. And when we talk about fires in our water application in those, we're talking about fires that have at least one room post flashover. All right, so we're not talking about going down to the end of a hallway and there's a bed on fire in the room. Right, I'm talking about at least one compartment on fire, probably vented to the exterior, at least if not to the interior. right? So the inside of our buildings, we don't have typically as much compartmentation as you guys do, right? So our spaces are typically open from one room to another. There's not always necessarily a door to be able to isolate on the way. So we isolate and control spaces with our water, right? And when we talk about surface cooling, we cool surfaces to cool gases, all right? So we want larger droplets. So the droplets go into the layer, they absorb heat, but they keep going, right? So then our droplets are gonna ride surfaces. They're gonna cool those, absorb more heat, and then come down the other side, right? We joke about the amount of water left, but that's why we're using large droplets, take the heat up, cool the surfaces, and then move on, right? So on our advance, we wanna try to keep the bail open as early and as often as we can. So when we're flowing water, right, we know that the nozzle and the water is gonna entrain air, right? And the more we move that stream, the more air we're gonna pull. But when we're on a straight or a solid stream, the air that we're bringing in with us is improving conditions behind the line, right? So if I'm going down the hallway and I'm flowing water in an O, right, the line is going back out the front door, I'm bringing fresh air in the front door, right? So behind the nozzle, I'm getting improvement in visibility, right? Oxygen concentrations are going back up. If you hear the term from the States, they're talking about put a line between the fire, you know, where the fire is and where the fire wants to go, or put a line between where the fire is and where the victims are, that's why, right? So putting a line there doesn't do anything unless the bail's open. When the bail's open and we're flowing water, we're improving conditions behind. If we're doing a pattern, you know, it doesn't need to be a hallway, it can be a wide open compartment. If we're doing a pattern and flowing and moving down the hallway or from room to room, we're bringing in fresh air, we're cooling all of those surfaces, we're keeping all the bad stuff out ahead of us, right? If we have a vent out ahead of us, even better, because then we can bring more fresh air in behind, right? If there's no vent ahead, we can only bring in so much, right? We don't have to worry about how much air you're bringing in with you because the vent controls that. If you don't have a vent out ahead, you're only going to be able to bring in so much. So in the States, we focus on surface cooling. As we go, we want to paint the ceiling, paint the walls, right? We're taking advantage of how much water we bring with us, 150 GPM plus. We want that to hit the ceiling, ride across the ceiling, ride down the walls, right? So in a couple seconds, we have taken that entire compartment and dunked it in a bucket of water. Right, so if you think about the example of like putting some water in a metal jar, right, and then bringing that to a boil, capping it off, and you dunk it in a bucket of ice water, what happens? That can shrinks, right? So we think about rooms as dunking them in a bucket of water, right? So, okay, I came to a bedroom, I want to cool this right now. Straight or solid stream application to the ceiling, right? Water rides to the walls, down the walls, across the floor. The surfaces are cool like that because we're bringing 150 GPM plus and we're hitting all those surfaces at once, right? When we get to the fire, it's the same application, right? So we get down to the end of the hall, you turn into the room, stream goes on to the burning contents, right? We start high first. We want those surfaces to stop re-radiating, cool surfaces, then we hit the base fuels, right? So on our advance, we focus on surface cooling, paint everything, nozzle open more often than closed, right? We focus on getting the nozzle open and moving with it open, right? There's a good line, Dennis Laguerre has the line, a closed bail flows no water, right? So only close the bail if you have to be able to move from one place to another, but you're better off in our attack with the nozzle open, right? If it's lights out and there's heat, bail open, flow and go, right? Use a thermal imager to figure out where the flows are from where the fire might be coming from, and then you work your water in that direction, right? So our focus is make sure we touch the surfaces, right? Because if we're bringing 150 GPM and we put it on a narrow fog, we're going to generate a lot of steam, right? So our approach is straight or solid stream, touch all the surfaces as quickly as you possibly can.
Everyone then spent some time familiarizing themselves with the various techniques and equipment. And believe me, there was some challenges. Whether it was absorbing more nozzle reaction with a combination or a smoothbore nozzle with a higher flow, or the rapid bail movements and pattern selection of the gas cooling technique and its surgical precision.
And then we went in and tried each other's tactics, and it was really eye-opening.
Okay, you're good. Thank you very much, man.
The fires were very hot and smoky with heavy OSB content.
We had some really good fires. They built great fires here. You know, it was judicial use of OSB, 20, 21 sheets in each burn. It was very effective.
We did quite a few evolutions, starting out with gas cooling, so everyone got a chance to experience what it was like. We were also able to have 3 or 4 additional firefighters in the burn room to act as observers.
In compartmental firefighting. The surgicalness of the 3D gas cooling or European style method, how surgical it can be and how done effectively, it works really efficiently, puts the fire out quickly.
If I was in a masonry environment and confined compartment fire, the gas cooling technique would be tremendous. It would work well, and we showed that here today.
It was good. It was definitely a unique experience. It was a great opportunity to share amongst countries around the world why we do what we do, because everybody has a reason why they do it.
This is going to be a fast push.
After that, we did several evolutions with a smooth bore surface cooling attack.
It was very interesting to see, for me being a European trained firefighter, how much heat the smooth bore nozzle can absorb as it advances forward. Absolutely amazing. It was impressive. Like, there was a lot of steam generated, but the steam was generally pretty cold compared to that pinching heat sometimes you get when you gas cool. I didn't feel hot, I felt wet. The firefighters from North America really got a lot out of gas cooling. I think that the firefighters out of Europe got a lot out of using the smooth bores, and they're two completely different techniques. They're both right for the right situations.
Most of their fire environments are going to be different than American fire environments, more compartmentalized. Our minimum water flow in the United States is 150 GPM, which is significantly higher than what they're talking about.
My worry when the exercise was about to begin was these guys would create so much steam. I was genuinely worried they were going to hurt themselves. But what actually happened, and we had a fire behaviour instructor in there with them, and they pushed all that heat energy with the movement that they used ahead of them. And even though it was wetter in there, it was actually easier and more comfortable, and dare I say, safer. We're already using smooth bores for high-rise firefighting, and we're happy with that decision. And as I said earlier, I learned more about how to do it here today than I knew from reading books or watching videos. But I'm 36 years in the fire brigade, and you get to a point where you think that you can't be surprised. You think that you've seen it all. Today I've seen something I didn't expect to see, and it's been hugely, hugely satisfying. And to be honest with you, in some ways inspirational as well.
I think the whole purpose of this mission is not necessarily to say we're right, they're wrong, or they're right and we're wrong. It's just to understand each other better. We kind of came up with the saying that, you know, there's nothing foreign about flowing water, right? And it's really played itself true in the last few hours.
The activities so far better prepared us for what we considered the public portion of the event. It was a two-day event, with day one being an open lecture series with various presenters, part of whom were people we had worked with in the hands-on in the previous days, and then a hands-on demonstration where the attendees were able to rotate through various hands-on stations. I myself was blessed to be a presenter. I felt much more prepared, having gone through the 2 days of preparations and had a better understanding of the dialogue that was different than mine. We did go deep into nozzle animations showing design. The conclusions we drew was, regardless of what the amount of water was being flowed, that the design and the firefighter interaction with it was something that needed to be concentrated on.
So the first day was a variety of lectures from across different parts of the world, talking about different strategies and tactics for high-rise firefighting.
The roles of the stairway protection teams: to prepare and maintain the stairway to ensure they remain clear of smoke.
We found that high-rise operations and tactics are something that can be shared across different countries more universally.
So I want to give you a little bit of background about UL and FSRI, the Fire Safety Research Institute, who we are, what we do, and what our function is.
One of the primary reasons we involved UL's FSRI and their presentation was not so much the approach of surface cooling versus gas cooling, but the total cumulative water flowed for a knockdown on a fire of a certain size. Some of the countries in attendance are somewhat compromised on the supply side of things, something we don't deal with much in the States. Some great conclusions that were drawn by attendees that I talked to was the total volume of water per knockdown of a fire of a particular size, as opposed to the obsession of how many gallons per minute is actually being flowed.
This is boom.
Oh, nice.
The second day was a hands-on day where we all came together and did a variety of different rotations, like we would do at a conference in the US. One of the rotations was building different high-rise packs, like the Denver fold and the New York fold, and applying it to the European-style hose and coupling setup.
New York City uses a blended hose line. 2 pieces of 2.5, 65, and 1 piece of 2, 52. And that 2-inch, 52, is the nozzle length. Raspberry. We can get through the apartment a lot faster if I have the smaller line.
We're learning a lot from our American cousins, and things like the hose packs, although we use them, that we don't really use them in the way that they use them. And I think we can benefit greatly from that.
We also had a rotation with specialty type nozzles, like the floor below nozzle.
This device is used for, guys, if you cannot make fire floors, and the other alternatives is floor below pipe. By introducing the water from the floor below into the window opening is what puts out the fire as water.
Our built environment is not hugely different to theirs. I think there's definitely space to take some of those tactics on board and implement them, or certainly tweak them to our needs, definitely.
One rotation was master streams, where we did exterior streams with the RAM portable ground monitor. We had a station where we did different handling techniques, harnessing nozzle reaction.
I squeeze it, lock my elbow in, and I want my arm to fully extend.
Trying different techniques with and without pistol grips.
Of course, for small countries like Luxembourg, to see what the other countries are doing, and we can learn from them. And then we can maybe use their tactics and their opinions in our country.
The smoothbore techniques are really interesting. It's something we moved away from probably 20, 30 years ago. We will now probably be coming back to implementing that into our attack techniques.
And finally, we had a UL FSRI style water mapping prop. In this prop, students are able to see how the water coats the walls and the ceiling and does different things inside the building.
We're coming with at least 150 gallons per minute, right? So even though that might be a brick wall and that's really hot and it is going to generate steam, right? That hot brick wall is only going to be hot for 1 or 2 seconds with 150 gallons. If everything for us is wet, it's less of a problem. You know, and the way we like to talk about it and teach it is you can always dry it out, but you can't unburn it.
Scientifically, the numbers, the facts, it does have a purpose. The only thing is that the insurance companies will have us. We can't go overhaul with the water. We need to gas cool compartments prior to entering.
You can watch a video and you can say, that's great, but it's not for us. But when you listen to people as to the rationale as to why, and you fully understand why they use those techniques, that's the interesting bit, and that's the bit that we're learning from at this event.
Well, as the event came to a close, the theme and conversation seemed to be somewhat consistent. As much as we thought we were different, we found we were the same.
No matter where you are in the world, you're all firefighters, we're all brothers, and that really showed.
We have a very diverse group, yet there's a common thread that runs through it all, and that's the ability for these special people that are called firefighters to do what they can for their community and work hard to improve themselves.
Everybody has the same passion for the fire service, but everybody's coming from a little different background. So it's very interesting to have those same conversations we'd have back home around the kitchen table, but here with folks from various cultures.
The Americans use an expression and it's called the brotherhood. There's something definitely individual about the firefighting fraternity that brings out a different connection. You don't get it with any other profession, I don't think. With the firefighting profession, we are all brothers and sisters.
When we're dealing with the UK, or the UK dealing with us, we say on the other side of the pond, as if it was water that separated us. Water is actually what connects us as firefighters. There's nothing foreign about flowing water.